In these problems, we're actually going to have to solve them before we begin graphing them. So let's look at this first problem that says x minus 2 is greater than or equal to negative 7. All right, if this was just a plain equal sign, then the first thing that we would do would be to add 2 to both sides to get x alone. Just because this is an inequality, our rules do not change. The only additional rule we have for inequalities is if you multiply or divide by a negative, you must flip the inequality symbol over. So when we add 2 to both sides, we now have x on the left-hand side, and negative 7 plus 2 is negative 5 on the right-hand side. We did not multiply or divide by a negative, so our symbol stays the same. Now we're going to write this in set builder notation, which means we're going to start out with a brace, which means the set of. And then we're going to put an x, so that means all x's. And then the straight line means such that. And then we write our argument and close the brace. This literally means the set of all x's such that x is greater than or equal to negative 5. Now we graph. We start at negative 5, and this will be a closed circle because there is equality here. So at negative 5, I put a closed circle, and the x's that are larger than negative 5 would go to the right. In our next problem, we have negative 9 plus y is less than 0. So we're going to have to add 9 to both sides first, which will leave us with y on the left. 0 plus 9 is 9 on the right. We did not multiply or divide by a negative, so our symbol stays the same. Written in set builder notation, this would be the set of all y's such that y is less than 9. And then to graph, we have to start at 9 with an open circle because it's not included, and everything that is smaller than 9 would be to the left. In our next problem, we have negative 8x less than or equal to 16. So to get x alone, we would have to divide both sides by negative 8, which leaves us x on the left, and 16 divided by negative 8 is negative 2. We divided by a negative number, which means we have to flip the inequality over. Written in set builder notation, this would be the set of all x's such that x is greater than or equal to negative 2. Here we're going to have to start at negative 2 with a closed circle because there is equality, and the things that are larger than negative 2 would go to the right. In our next example here, we have 3/4 y is greater than or equal to negative 2. So the first thing I'm going to do is multiply both sides by 4. Now we have 3y on the left. Negative 2 times 4 is negative 8 on the right. We did not multiply or divide by a negative, so our symbol stays the same. Now we're going to divide both sides by 3 to get y on the left and negative 8/3 on the right. We did not divide again by a negative, so our symbol stays the same. Written in set builder, this would be the set of all y's such that y is greater than or equal to negative 8/3. Now to get an idea of where this will be graphed, we need to actually do the division, and we find out that that is about negative 2 2/3. So we put our closed circle at negative 2 2/3, and the things that are greater would be to the right. Lastly, we have this example. In order to get x alone, we're going to divide both sides by negative 0.3, which leaves us x on the left and a positive 8 on the right. We did divide by a negative, so we have to flip the symbol over. In set builder notation, this would be the set of all x's such that x is less than 8. We're going to start at 8 on our number line with an open circle because there's no equality, and the things that are smaller will move to the left.